So question 8 show us a ladder, okay, with a plank. A panther is climbing up it. So given the mass of the ladder is 12 kg and the mass of the panther is 55 kg, and the ladder begin to slip at its base when his feet are 70% way up the length of the ladder. So the length of the ladder is not given, but then if we refer to the questions, so the base is 3 meter, the height is 4 meter, so we will understood that the length of the ladder will be 5 meter. So since the panther is standing at 70% of the length of the ladder, so I can calculate the position of the panther. 70% of 5 meter, so it will be around 3.5 meter. So it means that how far is the panther climb up before the ladder start to slip is around 3.5 meter. Okay, so the question asks us to find for the coefficient of static friction between the ladder and the floor. So it means that the floor is rough, so we want to find for the coefficient of static friction. What is the value of mu s? So in order to find the value of mu s, we can refer to the equations that we already learned before. We know that static friction force is mu s multiplied with the normal force. So the normal force here refer to the normal force from the wall, from the floor, okay, daripada lantai. So in order to solve this question means I need to calculate the normal force from the floor and also the static friction force. Barulah kita boleh cari berapa coefficient of static friction between the ladder and the floor. So to solve this question, I'm going to apply the condition for equilibrium, whereby I'm going to have summation torque will equal to 0 and the summation force along the horizontal axis x is 0. The summation force along the y-axis also equal to 0. So to solve this question, I'm going to draw the free body diagram for the ladder. So represent the ladder with length 5 meter. So what force is acting on the ladder? So we can start with the mass. So since the ladder have mass 12 kg, so assuming that the ladder is uniform, so at the middle point 2.5 meter, we are going to have weight of the ladder acting downward. I denote by WL. Okay, then because we have panther and the panther have a mass of 55 kg, so the panther is 70% way up the ladder. So at a position of around 3.5 meter, we have the weight of the panther, WP. Okay, then at the top end of the ladder is touching the frictionless wall. So touching the wall, so we have normal force from the wall. I denote by NW. Besides that, there will be also a normal force from the ground or the floor, because the ladder is touching the floor, so we have normal force from the floor. Okay, then we are going to have friction force, and this friction force will be acting towards right, Fs. So this will be 1, 2, 3, 4, 5 forces that acting on the ladder. Okay, after we complete the free body diagram, then we can start to solve our question. So maybe I can start with the easiest one. Maybe I would like to calculate the normal force from the floor. So I can use summation force along y-axis equal to 0. So I will notice that my normal force from the wall is acting upward, and the weight for the ladder and the panther is acting downward. So we have normal force from the wall minus the weight of the ladder minus the weight of the panther is equal to 0. So I can calculate the normal force exerted by the floor, which is equal to the weight of the ladder. So mass of ladder is 12 times 9.81 plus with the weight of the panther will be the mass of the panther times 9.81. So we will get the normal force from the floor is around 657.27 Newton. So I have solved the first unknown in order to calculate the coefficient of static friction. Now I need to calculate the static friction force. Okay, so I need to calculate the static friction force. So to calculate the static friction force, Fs, so I might apply another condition, summation force x-axis equal to 0. So if I consider all the force acting horizontally, I will find out that the static friction is pointing towards right. Then the normal force from the wall is pointing towards left. So minus the normal force from the wall, this one will equal to 0. So it means that the static friction force is equal to the normal force exerted by the wall. But then I cannot solve this value for static friction force because the normal force from the wall is unknown. So macam mana nak teruskan? So we are going to have the third condition, summation thought will equal to 0. So I try to calculate the normal force from the wall by using the condition summation thought equal to 0. So I'm going to choose my axis of rotation. So we take the end of the bottom of the ladder as our axis of rotation. Okay, so we take the end of bottom of the ladder as our axis of rotation. So I'm going to have torque produced by the normal force exerted by the floor plus with the torque produced by the friction force plus with the torque produced by the weight of the ladder plus with the torque produced by the weight of the panther and also the torque produced by the normal force exerted by the wall. All these must equal to 0 in order for the ladder to be in equilibrium. So, since the normal force exerted by the floor and also the friction is passing through the axis of rotation, so for these two forces, there will be no distance from axis of rotation. So, there will be no torque produced by normal force exerted by the floor and also there will be no torque produced by the friction force. Kenapa? Sebab dua-dua tu berada pada axis of rotation. Tak ada distance dari axis of rotation. Dan kita perhatikan, this will be my weight of the ladder. So how far is the weight of the ladder from the point of rotation? 2.5 meter. And this is the angle between the weight of the ladder and also the distance from the axis of rotation. This angle can be calculated actually. So refer back to this diagram. So actually I can calculate the angle. So saya tinggalkan sekejap. Kita kira angle dekat tepi ni. So kalau kita rujuk balik kepada gambar yang atas ni, So sini 4 meter, sini 3 meter. So teacher kira angle yang ini dulu. So I will get tangent theta will be 4/3. So I get the angle will be 53.13 degree. So sini teacher dapat 53.13 degree. So how about this one yang dengan vertical? So angle dengan vertical ni will become 90 minus 53.13. So it will be around 36.87. Okay. So kita dah dapat dah angle between vertical line tu 36.87. So saya boleh kira top dulu sini ya. So this one will be 36.87. So weight of the ladder will create torque that rotate the system clockwise. So it will be negative. The distance is 2.5. So the weight of the ladder will be the mass of the ladder 12 kg times 9.81. Then sine the angle between the distance and the force is 36.87. Okay, so that one will be the torque produced by the weight of the ladder. Then we have another one. Okay, now we calculate the torque produced by the weight of the panther. So how far is the weight of the panther from the axis of rotation? Is around 70% up the ladder. So is 3.5 meter. Just now we already calculate dekat sini. 70% way up the length of the ladder. So panther tu duduk pada kedudukan 3.5 meter. So same, this one will rotate the ladder clockwise. So we have negative. So the distance is 3.5. The weight of the panther will be 55 kg times 9.81. Sine the angle between the distance and also the weight is 36.87. So I put it in 36.87. Okay, so that one will be the torque produced by the weight of the panther. Then we have another one, the last one, the torque produced by the normal force exerted by the wall. So tengok sini. So this is the normal force produced by the wall. How far is the normal force from the axis of rotation? 5 meter. Then it will tend to rotate. It will tend to rotate the ladder anti-clockwise. So anti-clockwise will be positive. So the distance will be 5 meter. So the normal force of the wall we want to calculate. So the angle between the force and the distance will be this one. So this one will equal to 53.13. So the angle will be 53.13. So we put it in 53.13. So we already get the torque produced by the normal force of the wall. So all this will equal to 0. So then we solve it using calculator. So we will get the normal force from the wall will be around 327.41 Newton. Okay, so I get the normal force from the wall. It will be understood that I will get the value of Fs, whereby the Fs is equal to the normal force of the wall. So it will be 327.41 Newton. So after I get the value for NF and also friction, then I can calculate the coefficient of static friction. So Fs is mu Sn from the floor. So I can calculate the mu S. So the mu S will be the static friction force divided by the normal force exerted by the floor. So we are going to have 327.41 divided by 657.27. So we will get the coefficient of static friction is around 0.498. Then we solve the question.